Hello students, in this video we are going to discuss about the relationship between the zeros and coefficients of a polynomial. Yes, so you can see if I am talking about the standard form of a quadratic polynomial, so the standard form of a quadratic polynomial is given as, you know that it is given as px is equals to ax square plus bx plus c. Yes, so let alpha and beta are the two zeros of the polynomial, are the two zeros of the px quadratic polynomial. So here you can see, we can say that alpha plus beta, yeah, sum of the roots taking one at a time. So it means if I am talking about s1 alpha plus beta, so formula for alpha plus beta is sum of the roots taking one at a time is minus b by a. Yes, or we can also write like that, minus b means minus coefficient of x divided by coefficient of x square. So this is the formula which we need to keep in mind related to sum of the roots taking, or we can say that this is sum of roots formula. Yes, sum of zeros formula. Similarly, you can see product of zeros. We can say that alpha into beta, that is what, c by a. C means constant term here, constant term divided by coefficient of x square, coefficient of x square. So you can see here everybody knows, I think, a means what, coefficient of x square. Yes, in the quadratic polynomial, a means coefficient of x square, b means coefficient of x term. Yes, coefficient of x, and c means constant term. Everybody knows. Yes, constant term. Similarly, we can find the relation of zeros and between the zeros and the coefficient of cubic polynomial. So the standard form of a cubic polynomial, everybody knows. The standard form of a cubic polynomial, you can see, cubic polynomial is given as, so px we can write, and it is what, ax cube plus bx square plus cx plus d. Everybody knows here a means what, coefficient of x cube. A means coefficient of x cube, coefficient of x cube. B means coefficient of x square, coefficient of x square. Yes, and here you can see c means coefficient of x in the cubic polynomial. Clear? And d means constant term. D means constant term. So here let alpha, comma beta and gamma, yes, are the zeros of cubic polynomial. Cubic polynomial, yes. Then here you can see, if we are taking one, sum of the zeros taking one at a time. So here alpha plus beta plus gamma, sum of the zeros formula we have to write. So always keep in mind, and it is called S1 actually. When we are taking two root at a time, two zeros at a time, the sum of the zeros taking two at a time. So we can also write like that, alpha beta, beta gamma plus gamma alpha. Yes. And when we are taking all at a time, that is called S3. So it is what, alpha beta gamma. Yes. Or that is also called the product of zeros. So here you can see how to keep the formulas in mind. It's very simple. You can see always we can write coefficient of a leading term, in denominator. in each of the relations coefficient of x cube. You can see coefficient of x cube, yes, and here we will write the same thing, coefficient of x cube. Got my point? Now you can see how to write. Here you can see s1 means sum of the zeros taking one at a time. So here from here the exponent of x is what in coefficient of x cube? 3. So 3 minus 1 means 2. So here it will come coefficient of x square, yes, and here you can see here s1 in suffix is 1, so here it will be minus. If it will be odd, it will be minus sign. So the formula we can keep in mind, minus coefficient of x square divided by coefficient of x cube. We can also write like that, coefficient of x square is b, so minus b divided by a. This is the formula. Similarly, we can write the formula here, coefficient of x cube. So here you can see in suffix 2 is there, s2, right? Sum of the zeros taking 2 at a time. So from the exponent 3 we can subtract 2, so 3 minus 2 is what? 1. So it will come coefficient of x here, coefficient of x, yes, and here you can see we have 2 here in the suffix, so 2 is a even number, that's why here it will come a plus sign, yeah? So here you can see coefficient of x is c divided by coefficient of x cube is a. This is the formula. Here you can see alpha, beta, gamma, alpha into beta into gamma, so coefficient of x cube is already in the denominator. So here you can see suffix 3 is there. So 3 minus 3 is what? 0. So x to the power 0 is constant term. So here it will come constant term. But here you can see 3 is the odd number, so here it will come minus sign. So we can say that the formula is what? Minus d by a. In that way we can keep in mind the formulas of alpha plus beta plus gamma, alpha beta plus beta gamma plus gamma alpha, and alpha into beta into gamma, yeah? The relation of zeros and the coefficient of a cubic polynomial, yes. Now we are coming on the exercise. The same thing here we need to keep in mind, yes. We need to keep in mind the formula of alpha plus beta, yes, minus b by a is equals to minus coefficient of x divided by coefficient of x square, and here alpha beta is equals to what? C by a. So these are the formulas actually we need to keep in mind, yes. Now you can see one more logic I want to tell you. When sum of zeros and product of zeros of a quadratic polynomial is given, yes, polynomial is given, and they are telling please form the quadratic polynomial. So it's very simple, we can use the formula x square minus sum of zeros. This is the formula actually, keep in mind, sum of the zeros into x plus product of zeros. So we already have the product of zeros as well as sum of zeros. It is given in the problem, so we can use this formula and we can form the quadratic polynomial. So this is also you need to keep in mind, yes. Now we are coming on the exercise 2.2 of NCERT, yes. 2.1 we already did. So you can see this is the 2.2 exercise, and I am discussing this exercise now. Yes, in this exercise you can see the first question, exercise 2.2, they are telling find the zeros of the following quadratic polynomial and verify the relationship between the zeros and the coefficients, yes. So first question number 1, yes, first part, they are telling x square minus 2x minus 8. First we need to find the zeros, yes. So if you want to find out the zeros, so everybody knows how to solve the quadratic polynomial. So we need to find the prime factors of this and a constant term, yes. So that is coming what? If I will find the prime factors of 8, it will be what? 2, 8 divided by 2 is 4, again 4 divided by 2 is 2, 2, 2. So it means 8 we can write as 2 into 2 into 2. Yes, now we want two numbers whose sum should be equals to what? B, and B is here minus 2. Yes, A is here, you can see 1, B is minus 2 and C is minus 8. Yes, and we want two numbers whose sum is minus 2 as well as the product is what? AC. So AC is here minus 8. Got my point? So we need to arrange the prime factors of 8 in such a way so that the sum should be minus 2 and product should be 8 minus 8. So we can write like that, x square minus 4x plus 2x minus 8. Yes. Now we can take x common between these two terms. So x, if I will take common, so if I will take x common, so it will be x minus 4, and plus 2 if I will take common, so it will be x minus 4. X minus 4 we can take common from all, so it will become x minus 4 plus x plus 2. Yes. So I think everybody is understanding here. Zeros we are getting as, so here zeros of the polynomial are x minus 4 is equals to 0, so it will be 4, and x plus 2 is equal to 0 we can put. So we are getting x is equals to minus 2. Yes. So these are the zeros. Now we need to find sum of the zeros. Yes. Sum of zeros, because we need to verify the relationship also. Sum of zeros, so we can say that 4 and plus minus 2. So if I will add 4 and minus 2, it will be what? 2, and that will be equals to, we can see it is given what? B is minus 2 here, and A is given what? 1. So we can say that this is equal to minus, yes, coefficient of, because this 2 we can also write like that, 2 by 1, and minus coefficient of x minus coefficient of x divided by, here we can write coefficient of x square. Yes. So that is what equal to minus of b divided by a, because b is what? It is given b is minus 2. So minus 2 into 2 is what? It will be 2 divided by a. A means what? 1. So we can say that sum of zeros is what? Minus b by a. Similarly, product of zeros. So product of zeros is what? 4 into minus 2. So 4 and minus 2 we can multiply. So it will become what? Minus 8. Yes. And minus 8. So here you can see we have c. C we already checked, it is minus 8. Yeah. So we can say that minus 8 by 1. Minus 8 by 1. So we can say that it is equal to constant term divided by coefficient of x square. Yes. So that is c by a. So you can see product of zeros equals to c by a, and sum of zeros is minus b by a. So in that way we can verify the relationship between the zeros and the coefficients. So similarly we can do the other questions also. Yes. And we can do one more question. You can see the question number third. It is given 6x square minus 3 minus 7x. Yes. 6x square minus 3 minus 7x. Yes. So first we need to write this problem. Yes. In form of standard form of a quadratic polynomial. So 6x square minus 7x minus 3. So here we want two numbers actually, whose sum should be equals to what? Minus 7, and product should be equals to a into c. Yes. Minus 7 means what? B. And product should be equals to AC. So 6 into minus 3, if you will do, it will be minus 18. Here everybody knows A means what? Coefficient of x square. C, B means minus 7, and C means what? Minus 3. Yes. So here you can see, now we need to find the prime factors of 18. 2, 9, 3, if I will divide 3, 3, if I will divide, it will be 1. So now we need to arrange in such a way so that the sum should be, so here we can say that 9 minus 2. Yes. So minus 9 plus 2, it will be minus 7. And if I will multiply minus 9 into 2, it will be minus 18. So I think that will work out, yes, for us. So 6x square, and we can write minus 9x plus 2x minus 7x. Yes. And minus 3. Here, yes, here it should be only minus a. Yeah. Yes. Minus 3. So here you can see between these two terms, 2x is common. So 3x is common. So we can take 3x common. So it will be what? 2x minus 3. and here between 2x minus 3, 1 is common, so we can say that 2x minus 3. So 2x minus 3, we can take common from all, and 3x plus 1. So we can say that actually the zeros are 2x minus 3 is equals to 0. So from here x is 3 by 2, and 3x plus 1 is equals to 0. So we are getting x is equals to minus 1 by 3, yes. So here we are getting two zeros, 3 by 2 and minus 1 by 3, yes. So 3 by 2 and minus 1 by 3 are the zeros, are the zeros of the polynomial, yes. Now you can see sum of zeros. We can say that sum of zeros is what? So sum of the zeros is 3 by 2 plus minus 1 by 3. So if I will find, so here you can see we need to take the LCM. So LCM will be what? 6. 2 and 3 LCM is 6. So 2 3 is 6. So 3 3 is 9. And 3 2 is 6. So minus 2. So here we are getting as 7 by 6. Yes. Now we are coming on coefficients. The coefficients are what? A, B, C. So coefficients are A, B is minus 7 and A is 6. So here we can see this is minus 7 and here we are getting 7. So we can say that this is minus of B and A is 6. So minus B by A. So sum of zeros is minus B by A. Now we can see product of zeros. So product of zeros is what? We have number 3 by 2 and minus 1 by 3. So if I will find the product, 3 3 cancel and we are getting what? Minus 1 by 2. So here you can see minus 1 is the value of, we can check. Yes, here you can see C is minus 3, yes. And here we are getting A, so C is, okay. So here you can see if I will find C by A. So C is given minus 3 and A is given 6. 6. So if I will find, that will be what? Minus 1 by 2. So this is what basically C by A, yes. So in that way we can verify the relationship of of question 3, yes, of exercise 2.2. Similarly, we will do the other questions. You can see, yeah, this question is done, yes. Similarly, we will do the other question, question number 2.